Okay, so we are doing a video that is going to relate directly to the Pearson online assignment. Has the same topic. It says solving system of equations using substitution. It should be assignment 7. So if you've noticed, I've changed the way I'm labeling things in Focus to try to match up the videos with the assignments a little bit easier. But sometimes assignments are going to get out of order. There's not much I can do about that because, frankly, sometimes I'm going to have to not grade an assignment because nobody did very well on it. So that may change the way it matches up. But as long as you look up the title and try to match it up to the best of your ability with the focus assignments, it should at least be the same content and should help you with those particular assignments. So again, this is for the next Pearson assignment. Pearson is your online book. I already have a video on how to get that, a couple of videos, so you can go back and look at those, look at themes, look at focus. They are, the links are posted in there. I don't think both of those are on YouTube. They might be on YouTube. Actually, I think they are on YouTube, but you can definitely get to them through Teams. And you have to go to the live sessions team, not your period, not period 1, period 3, period 5. You need to go to the live sessions team for some of the videos because I've recorded some of the live sessions. Let's go to the lesson. Solving system of equations using substitution. When do we do that? We've already talked about graphing and when to do graphing, and graphing made sense when we had lines that were easy to graph. That's kind of a simple version of it. We know how to graph pretty well, hopefully still, when the line is in the equation y equals mx plus b. It's like this blue equation. We have two equations though. Again, a system of equations means we have multiple equations and multiple variables, but only one solution that's going to work for both of these. So one of them is pretty easy to graph. Unfortunately, one of them is not easy to graph, not as easy. So this is a situation when maybe graphing is not the best idea, especially if we're not real comfortable with graphing in the first place. It's a little harder to graph this red equation. If you know how to do it, then you can certainly try to solve those that way. But there's another problem. So in addition to these not really being in simple forms to graph, if we do graph them, which I've done over here, if you'll notice, the point where they connect, the point where they cross is the solution. Because again, all of the points on this line are solutions to one equation, the blue equation. All of the points on this line are solutions to the red equation. So that means this point where they cross must be a solution to both equations. Simple as that. Well, that's the solution. The problem is, if we look at that solution, we'll use green. If we zoom in on that a little bit, not that I really need to for you to see what I'm talking about. If we zoom in on that a little bit, or a lot, down here in the corner now, you see that those lines don't really cross in spots that are easy for us to determine the values. I could estimate, so if I'm trying to find, and your answer, by the way, and I'm seeing this on the assignments turned in, we're not sure what the final answer is, like how to write, what form to write it in. The final answer when you're doing a system of equations is an x and a y value. So you would write the x and the y value of whatever the lines cross, or if you're doing it through substitution, you'll write the x and the y values that you calculate. But if you look here, well, my x value, I figured out by looking at this axis down here. This is the x-axis. Well, I'm a little less than 1, because we see 1 right there. So I'm a little less than 1, so maybe I'm at 0.8, but I can't tell exactly where I am. It's impossible to tell exactly. So if I guess, like if I estimated, which sometimes they do ask you to estimate, I can say, well, I think my x is about 0.1. Well, now for my y value, I'll change to, well, I can't change to blue, I'll change to purple. So my y value is based on the y-axis. So where am I relative to the y-axis if I'm looking at this intersection that's circled? Well, maybe I'm like right here, like Maybe I'm somewhere where that is, so maybe 2.5. But again, I can't tell exactly where I am. So I would just be estimating 2.5. That's about the best you can do is estimate when you're graphing. So now if this would have landed nice and perfectly on one of the corners, like any corner that's in this whole graph, doesn't matter, any corner, then I would say, okay, well, that's 3, 3. Or if it was on this corner way over here, if that's where they crossed, it would have been negative 3, 4. So then you can tell. So that's, I think, another answer to your next assignment. Basically, is if the answer is nice round integers, then it's easy to use graphing also in those situations. If it's not integers, though, you can't use graphing. It's just not the right. So with that in mind, let's solve out some problems. So I've given you some difficult ones in it. Difficult just meaning that the math is a little tougher. There's no fractions, I don't think. So same process though. So what we need to do first is we need to solve for one of the variables. And the only way you can solve for a variable is if you have one equation and one variable. Or 2 equations and 2 variables, but we need to get it down to where it's just one equation, one variable. So I need to somehow say, okay, well, I need to get rid of one of the variables in this equation right here. And I need to get it down to where it's just a single variable. And I'm going to solve then that one equation using just a single variable. Well, I know that y right here is equal to all of this. So it's the same thing. We talked about substituting. If you go into a game for another player, then that player comes out. You substitute it in for him. If I have a substitute teacher, I leave the class, I'm not there, and that substitute teacher comes in. Right? But the key point in that is not only do you take one out and put one in, but they're equal value when you think about it in math. I could have y or I could have 6x plus 7. They're the same value. It's kind of like I could have $1 or I could have 4 quarters. They're worth the same thing to me. So that's an easy way to think of substitution. $1 is the same thing as 4 quarters. 5 ones is the same thing as a $5 bill. I could take either of them. So instead of using this y down here, I'm going to say, well, you know what? I know that that y is equal to 6x plus 7. And if I got rid of that y and I put in 6x plus 7 instead, well, now I'd only have one variable in the bottom equation. So with one equation and one variable, I can solve it. So that's exactly what we're going to do. So I'm going to say, all right, well, I know that I still have the 3x, right? I'm not doing anything with that because I'm substituting in what y is equal to. Well, y, oh, and then I still have the subtract 8. That will not go away. Numbers will never go away. If you, that 3, that negative 8, that 4, those will never go away, not until after you start doing math. But the y value will. And I can say, okay, well, I know instead of that y right here, instead of that y, I'm gonna replace it with 6x plus 7, because I know that's the same thing as y. Again, it's like saying, well, instead of having $1, I'm gonna put in 4 quarters. So now the 4 doesn't go away, like I said. Now we just need to do the math. So I'll start a little bit smaller now. So we say 3x, we don't do anything with that. Now I need to say, okay, well, this is negative 8 times positive 6x. So that's going to become subtract 48x. I can't figure out the x. Now I have negative 8 times 7. Oh, I don't like this in there. Let's put this up here, negative 8 times 6 and negative 8 times 7. So now I say negative 8 times 7 becomes negative 56. And then I just say that all is still going to equal 4, because we didn't do anything on the right hand side. So now I need to look for like terms. Here are my like terms right here. The x's are like terms. And I'm looking for like terms on the same side of the equation. That's a key. So I'm going to combine those. I'll actually just change to red for this step. So 3x subtract 48x is negative 45x. And then I still have the subtract 56. And then that still equals 4. Right? So my next step is I need to get x all by itself. So this variable is what I'm solving for right here, x. I need to get that all by itself, which means I need to get rid of this number, negative 56. So I'm going to add 56 to cancel out. So that'll all cancel out. But if I add 56 there, I've got to add 56 over here. So that means I get 4 plus 56 gives me 60. I still have negative 45x over here. So that gives me negative 45x equals 60. My last step is always division. Wrong number. So I divide by the entire number, including the negative. I do not divide by the x. Remember, whatever variable you're solving for, you will never do math with that variable. You're just trying to leave it there to get it all by itself. Well, that means I need to divide by negative 45 over here. And then that would give me x equals, so that all goes away. I still have the x left. X equals negative 4/3. If you did it on a calculator, you'd get negative 1.333333 repeating. Negative 4/3. There. So that's one of our part of our answer. We are not done. This is the part you guys hate. Oh, Mr. Gill, that's too much. That's too much. So, I'm just like you guys. So, now though, I have to say, okay, well, if I know what x equals, I still have two variables. I have a y. I don't know what y equals yet. And the final answer is x comma y. Whatever your x value is, comma, whatever your y value is. So I'm just going to go up and I'm going to pick, you can pick either equation. I'm going to pick the top equation because I feel like that's just going to be easier to solve for y since y is all by itself already. So over here, I'm going to solve for y. Solve for y. That was a little sloppy, but. So y equals, again, the numbers don't go anywhere, so I still have 6. Now, though, x is negative 4/3 because I solved for x a little while ago, and then plus 7. So negative 4/3. I don't really love negative signs, so let's get rid of that. Negative 4/3. Right, so again, y, I don't do anything with y. 6 times negative 4/3 would be negative 8. And then do anything with 7. So y is going to equal negative 1. So that's my final answer. Well, actually, my final answer would be written like this. Negative 4/3 is my x value. Negative 1 is my y value. If you get some math wrong, I'm not going to really count off much at all for that. As long as you show me you went through the steps to try to solve, and then you plugged whatever number you get, even if it's wrong, you plug that in for the equation to solve for the other variable. That's the important thing. I'm not even going to go back up. I should go back up, but I'm going to try to keep this short. I should go back up and take these two values right here. I should take those two values, and I should plug them back in to that equation. And I should make sure that the left side equals the right side. Remember, if we take our final answer and we plug it back in, it should make the equation true. It should make the left side equal to the right side in this case. I'm not going to go through that. I want to do a couple, actually several more problems. So let's do this one now. Same process. So y is equal to 2x subtract 1. So I'm just going to start solving. I'm going to do this a little quicker. 2x doesn't go anywhere, 3 doesn't go anywhere, but now I can replace this y with what y is equal to, which in this particular equation is 2x subtract 1. And then I still have the negative 7 instead of with a negative 7. All right, so now I do the math. 2x plus 6x subtract 3. Again, I just multiplied the 3 times the 2x to get 6x, and the 3 times the -1 to get subtract 3, -7, 8x subtract 3 equals -7. Now I need to get rid of this 3, which means I add it on both sides. So I get, cancels out, 8x equals -4. I divide by 8, divide by 8. And I get, extend it a little bit, I get x, because those cancel out, equals -1/2. Right. Again, not done. Not done. So now I got to solve for y. So my last step is solve for y. So y, I'm going to use the top equation because it just seems easier. 2 doesn't go away. X is now -1/2. And then subtract 1. If you'll notice, these 2's are going to cancel out nice and easy. So that's kind of a hint that I probably did the math correctly when I go to solve for y and the 2's cancel out. You can do this in a calculator. You could change -1/2 to -0.5. That might be easier. So I'll say y now equals -1, subtract 1, y equals -2. So my final answer is in the form of an x comma y, -1/2, because that's what x was from over here on the left, and then comma -2. So that's my final answer. Remember, even when you're graphing, your final answer is always a number, comma, a number, if there's only one solution. And we're going to get to the other 2 possible options coming up right now. So next page. So there are some scenarios when you get a weird answer, basically. And that's fine. You might get a weird answer. It can certainly happen. So let's go through what those are. I don't know if one of these is going to happen in your book or in your assignment. It might, so I'm going to go over them. It might not. You might just get something like the first 2 examples we just did. So let's go ahead and we'll do start in red. Again, I know that y equals that, so that's my key that I'm going to be able to substitute in something for the y variable down here. So I said 6x, that doesn't change. Subtract 2, that doesn't change. Numbers never change. But now instead of y, I know y equals 3x plus 1. And that all equals -2. All right. Cool. So I can say, well, I have 6x here, 2 times 3x, and then, I'm sorry, -2 times 3x, and then -2 times 1 is going to give me subtract 6x, and it's going to give me subtract 2 equals -2. Here's where the weird stuff starts going. It's where things just get crazy. So 6x and 6x are like terms. If I combine them, I get 0. 6x subtract 6x is 0. Well, that's weird. And then I have to subtract 2 still equals -2. So basically what I'm looking at is -2 equals -2. This is where a lot of you make mistakes because you feel like you shouldn't have gotten that answer, but it's possible. If I come up with an answer like that, -2 equals -2, or 6 equals 6, or 1,000,000 equals 1,000,000, basically 0 equals 0, I get the same number on the left and the same number on the right. That means no matter what numbers I plug in to those 2 original equations in this system of equations, I will always have the left be equal to the right. If we graphed it, it's one of those weird scenarios. Ooh, let's do this in black. It's one of those weird scenarios. If we have a graph right here, if I graphed a line, and this is not the graph for the 2 lines that above, I would graph one line there, and when I graph the other line, it would be right exactly on top of the other line. So those two lines are touching at every single point on the lines. So that means it's an infinite number of solutions. So this is a scenario when you get this type of answer, the left side, a number on the left, and it's the same number on the right. It's infinite number of solutions. So that's one of the unique cases. Here's the other unique case. It's kind of similar to that. Again, I see y is equal to that. So I can say, well, you know what? I'm going to just plug in. So 5x doesn't change. I now know that my y, though, is equal to 5x subtract 4 right here. So I'm going to plug in 5x subtract 4. I don't need parentheses this time because there's no coefficient to this y right here. So there's nothing to multiply by. So I don't need any parentheses. And that's just going to equal -4. All right. Well, again, I get something weird. This is not the other scenario. Well, darn it. Right. What's going on? Oh, okay. What did I do wrong? Oh, I did. I do need parentheses. I am totally incorrect. I do need parentheses because it is going to matter. So technically, I would say there's a 1 there. It's a negative number. So it has -1 there. This is important. So even if you don't understand what's going on, you need to understand this concept. So technically, this is, I'm going to zoom more in on this. I can't zoom in a whole lot more, I'm afraid, but I'm going to try. Oh, I can't zoom anymore. I'll just rewrite it above. So this top equation is technically 5x subtract 1y equals -4. Well, I need to take into consideration I have a negative there. So I do need to write the parentheses, and now I get 5x -1. So this would be a -1 times 5y, because even though you don't see a 1 after that negative, technically it is. So subtract 5y. Now, though, I have negative. I'm going to change this to. So 5x subtract 1 times y. So it's -1 times 5y and -1 times -4, which gives me +4 now. And that equals -4. Again, those are. Well, shoot. That's an X. I was replacing y, so y should no longer be in this equation. So 5x subtract 4 replaced this y right here in the bottom equation. So now these two like terms cancel out, so I get 0 plus 4 equals -4. Well, now I get a different scenario. I get a number on both sides. I get +4 and I get a -4, but they're different numbers. Does +4 equal -4? Well, no, absolutely not. They're different numbers. They can't be equal to each other. The only number that's ever equal to itself is that same number. This is an incorrect statement. That is not a correct statement. This was a correct statement or a true statement. This is a false statement over here. Oh boy, that looks like an X. So this I'll write false. So this is false over here. This is true over here. If you get a false statement, like +4 equals -4, that means there is no solution. That just doesn't make sense. That can't. So there is no solution to this scenario. On a graph, what it would look like, you have your x and your y plane, x, y, that was x, y over here, and you would graph the line. And again, this is not the same exact equations as up there, but we'll make it a negative line this time. So we have a negative line there. If we graph the second line, it would be another line that ran parallel. Those are supposed to be straight. So it would be a parallel line. It would run right alongside of the other line. They would never touch. And remember, the point where lines touch is the solution. So if they never touch, then there's no solution. That's why that's the case. Right, so that should help you with the assignment in Pearson. Again, I believe this is assignment 7. It's the first assignment in Pearson about, well, just look at Pearson. It's about solving system equations through substitution, which will probably have 2 or 3 assignments on that, but this one will help you with all of them in another video. If you need help, message me in Focus. You can also get help in Pearson. If you look in the upper right corner where the problem is, it says question help, so you can get question help that way. You can post on Teams to the assignment that you need help on, like just ask questions in that feed and that post. And I think that's it.